Good morning, everybody. Today, we will consider the last topic or the point left or the characteristics of fluids at rest. That is, fluids at rest exert pressure everywhere at all points within the fluid, also on walls of the container. So today we'll discuss about the pressure exerted by fluids at rest. This is the last point to be covered while studying hydrostatics. That is, different characteristics shown by fluid which are at rest. So, Patil madam has covered the expression for pressure exerted by fluid at one specific point at depth h from the free surface of liquid. She has covered already this topic. You derive the expression with discussion with her. P is equal to H rho G. Madam, page number, okay, wait. Page number 28. I am covering the last point while studying characteristics of fluids at rest, that is pressure exerted by fluids at rest. I have started 2.3.1. 2.3.1. Adjust the camera means what you expect. Is it clear now? Is it clear now? Your microphone is unmuted. Is it clear now? I hope it is clear. We'll proceed further. So at every point to depth h means if you consider the points lying at same horizontal level, they experience the pressure due to fluid only equal to h rho g. But you know the atmosphere air is present, so air is also fluid. So Earth's atmosphere at the same time also exerting pressure at the free surface, and at the free surface it is always constant. So net pressure experienced by point within the fluid at depth h below its free surface will be then total pressure, which is called absolute pressure. Atmospheric pressure plus pressure exerted by fluid column, that is H rho g. You remember all these points well. This is called absolute pressure. This is atmospheric pressure. And difference between P and P naught, total pressure experienced by the particle minus atmospheric pressure is called Gauge pressure. Generally, when we talk about pressure within the liquid fluid at rest, we neglect this atmospheric pressure. ये हम लोग निगलेक्ट करते हैं और यू टेक total pressure experienced equal to pressure exerted only by liquid column. But it is not so. Total pressure is the sum of atmospheric pressure and H rho g. What is atmospheric pressure? Its value is considered standard. It is the pressure exerted by air on 1 meter square area of Earth's surface at sea level. Sea level is considered as zeroth reference level. You have to make the column. एक कॉलम बनाना है, उसका बेस एरिया कितना चाहिए 1 मीटर स्क्वायर. It has length up to entire atmosphere. वो तो ऊपर जाएगा ही, पूरा एटमॉस्फेयर का उसका हाइट है. तो the total pressure exerted by such air column at sea level is considered standard atmospheric pressure, and hence this pressure is always there on Earth's surface. The height of beaker on the platform above the Earth's surface is negligible. So you can consider the beaker kept on the Earth's surface as good as that one, and hence P is equal to P naught plus H rho g. So actual total pressure experienced by a particle at depth A inside the fluid is P naught plus H rho g, where rho is density of the fluid and H is its depth from the free surface. Atmospheric pressure has standard value and it is 76 mm of mercury. You all know that value. So this is all about pressure experienced by a particle within fluid at depth h from its free surface. It has three terms: total pressure, atmospheric pressure and gauge pressure. So atmospheric plus gauge pressure gives you net pressure experienced by that particle inside the fluid. The difference between absolute and atmospheric pressure is called gauge pressure. So this is the article to be discussed. So I have covered 2.3.2. Also the point 2.3.3. Absolute pressure is net effective. It is made up of two parts, atmospheric and gauge. Addition of both will be the total pressure experienced by a particle within fluid. If the particle lies outside the fluid, then it will experience only atmospheric pressure. Gauge pressure it will not experience. Even air is fluid. The atmospheric pressure is the pressure due to air column. So remember all these points well. So I have discussed 2.3.1, 2.3.2 and 2.3.3. So we will proceed further to point 2.3.6. डायरेक्टली हम लोग पहले 2.3.6 कवर करते हैं, in which we measure the pressure. 2.3.6 on page 32. डायरेक्टली मैं 32 पेज पे गई हूँ. ओपन पेज नंबर 32. On page 32, they have proceeded with measurement of pressure by noting the point 2.3.6. The pressure is recorded with the instrument. Generally, the name of the instrument is pressure gauge or pressure meter. These pressure meters are of different types. We have to study only two out of all. First is mercury barometer and the other is open tube manometer. These two are used फॉर प्रैक्टिकल पर्पजेस अप टू 12th स्टैंडर्ड। जैसे आप लोग आगे आगे जाएंगे तैसे आप लोगों को ये बाकी के मैनोमीटर्स वगैरह है उसका यूज करके प्रेशर रिकॉर्ड करना है। एट दिस लेवल up to 12th we'll consider only two, mercury barometer and the other one is open tube manometer. Actually barometer is the word used for the instrument which records atmospheric pressure। जो atmospheric pressure है ना उसके लिए बैरोमीटर यूज किए जाते हैं। सो रिकॉर्डिंग ऑफ एटमॉस्फेरिक प्रेशर इज डन बाय बैरोमीटर। वाइल ओपन ट्यूब मैनोमीटर में क्या होता है, वी गेट द प्रेशर यूजिंग यू ट्यूब मैनोमीटर। So that too we can take, and why they work on the principle at all particles at same height। इधर एक पार्टिकल है, ये आर्म में इधर एक पार्टिकल है, इधर ए पार्टिकल है, सपोज इधर बी पार्टिकल है, बट दे आर एट सेम height level। So pressure at A is same as pressure at B। On this principle they work। So you remember these barometers also। So the recording of pressure is done using these two instruments and the detailed study of that is given in the book। There is nothing to discuss about the working of this barometer and manometer। You can easily go through the book and can get the point। डायग्राम देखो, पॉइंट है वो एच पॉइंट दिया है, पी ए पी बी। आई एम टॉकिंग अबाउट डायग्राम नंबर 2.14। देखो बी पॉइंट और सी पॉइंट दोनों एक लेवल पे है। सो दे हैव टेकन बी पी इज इक्वल टू पी बी। PC is equal to PB। बाद में उन लोगों ने क्या लिया है, B is the point inside the fluid। So total pressure is atmospheric plus H rho G। Also P pressure on point C is atmospheric pressure। So pressure will be PC, and when you add them together you will get P। So it is just as simple as we studied। So it is nothing to discuss in that। Also बैरोमीटर में भी कुछ डिस्कशन का जैसा है ही नहीं, पूरी थियरी है, आप पढ़ो, ये आप लोगों को ये मिल सकता है। सो ओनली रिमेंबर 3 different pressures। एब्सोल्यूट यानी कि टोटल प्रेशर। Absolute is addition of atmospheric and pressure exerted by fluid, and that pressure exerted by fluid is experienced only by particle inside the fluid। This is the main thing। So based on the technique, pressure at one level at all points is same, you will get one more interesting phenomenon which is called hydrostatic paradox। So we will switch over to study hydrostatic paradox। सब ये फिनोमिना में कंसेप्ट एक ही है, एट वन सेम horizontal level pressure experienced by all particles is same। यही के ऊपर हम लोग डिफरेंट फिनोमिना स्टडी कर रहे हैं। सो आई हैव स्टार्टेड पॉइंट 2.3.4 नाउ ऑन पेज नंबर 30। मैंने 2.3.6 पहले कवर किया, उसके प्रेशर मेजरमेंट के पहले, और बाद में मैं चालू कर रही हूँ। तो हाइड्रोक्सिक पैराडॉक्स क्या रहता है, आप लोगों को मालूम है, यू हैव नंबर ऑफ वेसल्स। These vessels can have different capacities as well as different shapes। I will select few vessels having same base area। एरिया सबका सेम चाहिए, बेस एरिया एंड डिफरेंट शेप्स। सेम बेस एरिया चाहिए, बेस एरिया उन सब वेसल्स का सेम चाहिए। दे कैन हैव डिफरेंट शेप्स। like this. I will interconnect all of them. ये मैंने सब को कनेक्ट कर दिया. All are interconnected. Suppose this is vessel A, this is vessel B, and this is vessel C. It is observed if we pour any fluid, suppose common fluid used is water, so they have put name hydro. Hydro means water. कौन सा भी फ्लूइड ले सकते हैं. If I pour it in vessel A, it is observed it moves in B and C also. Go on pouring a definite quantity of fluid. Then it moves in B and C also, but at equilibrium, when the work is complete, the levels of liquid in different containers remain same. The liquid rise, liquid column fall in each container. H3, this is H2 and this is H1. But H1 is equal to H2 is equal to H3. ये कंटेनर छोटा है, ये कंटेनर की कैपेसिटी कम है, तो इसमें लिक्विड ज्यादा ऊपर आएगा, ऊपर तक भरेगा, और इसमें कम हाइट तक भरेगा, ऐसा नहीं होता है. So only the condition their base area should be the same. If base area is same, liquid poured is remain at same level in all three vessels, and this is due to the pressure at base of each container should be same. प्रेशर ऑफ एट बेस सेम है, तो ये ऊपर वाली लेवल भी कैसी रहेगी, सेम मेंटेन होएगी. तो दिस इज कॉल्ड हाइड्रोस्टैटिक पैराडॉक्स. व्हाट इट इंप्लाइज, द लिक्विड कॉलम height in all vessels of different shapes of different volume capacities remain same in equilibrium when what fluid is poured in any one of these, because pressures at base points they are also at same energy level is same. So many times we get hydrostatic paradox and we can use this concept for further. The liquid never overflows. ये overflow नहीं होता है, उसका कैपेसिटी अगर कम है तो भी सबका सेम आता है. So this is concept of hydrostatic paradox. One more thing you can study for fluids at rest. एक मैंने फ्लूइड लिया है, वो मैंने एनक्लोज किया है, मैंने पिस्टन लगा दिया, मैं पिस्टन लगाती हूँ, एनक्लोज किया है. Suppose here it is an enclosed fluid. I will have the openings. मैंने इधर ओपनिंग्स बनाए और इसमें ट्यूब लगाए. लास्ट टाइम वी डिस्कस दिस पास्कल लॉ, इधर भी मैंने ट्यूब लगाया. इनिशियली एट इक्विलिब्रियम नो एक्स्ट्रा प्रेशर. अभी मैं क्या करने वाली, आई विल exert force on this enclosed fluid. Then if these are, इधर भी मैंने पिस्टन लगाई है, देखो इधर भी मैंने पिस्टन लगा दिया, इधर भी एक पिस्टन लगाया है, इधर भी मैंने एक पिस्टन लगाया है. Initially all the positions of pistons fixed है. When this piston exerts force F on this enclosed liquid, then all these pistons move a little back. ये जो मूवमेंट है ना, मूव बैक होते हैं. और if you want to have the pistons to be at same position, extra external force is to be applied. ये जो फोर्स है ना, उसका एरिया क्या है, ये पिस्टन का एरिया ए है, ये पिस्टन का एरिया A2 है, या पिस्टन का एरिया A3, इधर एरिया क्या है A4 है. These pistons move to the same extent in backward direction. एरिया अलग है तो इधर हम लोगों को F2 फोर्स लगाना है so that the position of piston will not change. Here also you have to apply force F3 upward so that piston will not move backward. So this force developed or pressure developed is same at all points, undiminished, equally everywhere. This is called Pascal law. Pascal law is useful only for enclosed liquids which are at rest, no motion. So we are considering now further the Pascal law. The point 2.3.5 on page number 30 again, Pascal's law. अनडिमिनिश यानी कि एनर्जी कहीं वेस्ट नहीं हो रही है. मैंने फोर्स F लगाया ऑन एरिया A, सो फोर्स F बाय A इज ऑब्जर्व टू बी इक्वल टू F1 बाय A1, यानी कि इधर एरिया कितना है, ये बाजू A1 है. तो अगर पिस्टन को नहीं मूव होना है बैकवर्ड डायरेक्शन में तो जरूर जाएगा. अगर उसको बैकवर्ड डायरेक्शन में नहीं मूव करना है तो यू हैव टू अप्लाई फोर्स F2 टू हैव इट्स पोजीशन सेम, सो दैट F2 बाय A2 it is proved experimentally it's same as F by A. This is Pascal's law. It has wide applications. The main application is hydraulic lift. Lift यानी कि क्या है, उसमें क्या होते हैं, there are two cylinders. दो cylinders रहते हैं. They are interconnected. Each cylinder carries piston. दोनों cylinders के एरिया, क्रॉस सेक्शन एरिया अलग अलग है. Areas of both cylinders. इसका A1 है, the cylinder A, इसका A2 है, this area of the piston in contact with fluid, and this is B है. ऐसे होते हैं. तो क्या होता है, अगर मैं ये पिस्टन नीचे दबा दूं, सपोज थ्रू डिस्टेंस S, तो नया प्रेशर क्या डेवलप होगा, फोर्स F1 है, एरिया A1 है. सो फोर्स पर यूनिट एरिया इज नथिंग बट प्रेशर. सो प्रेशर एट पॉइंट ऑन द सिलेंडर A विल बी P1. अभी ये अनडिमिनिश्ड जाएगा, यानी कि सेम प्रेशर शुड रिमेन सेम. सो प्रेशर डेवलप इज इक्वल टू P2 and P1 should be same as P2, undiminished है. सो एरिया ज्यादा है, प्रेशर सेम रहना चाहिए, P1 should remain same A2. सो अगर एरिया ज्यादा है तो जो फोर्स डेवलप होगा P2 F2 inside that should of greater magnitude in comparison with F1 के हिसाब से वो ज्यादा मैग्नीट्यूड में चाहिए. इसलिए क्या होता है, हेवी व्हीकल इधर रखा और स्मॉल मैग्नीट्यूड का फोर्स अप्लाई करा तो हेवी व्हीकल कैन बी इजीली लिफ्टेड अप. सो दिस इज कॉल्ड हाइड्रोलिक लिफ्ट. द अनदर एप्लीकेशन इज हाइड्रोलिक ब्रेक. हाइड्रोलिक ब्रेक में भी ये यूज किए जाते हैं. सो इट just multiply the force applied. Small force applied gets multiplied and can be utilized for raising of heavy vehicles. This is its technique. So today we'll completed all points, that is all characteristics of fluids which are at rest. From next time we'll begin with to study the characteristics of fluids if they are in motion. So from next time, we will begin with hydrodynamics. Dynamics में जाएंगे, fluids in motion. So today I am stopping the meet.